So finally, we'll look at the intramolecular Claisen condensation, and this is usually referred to as the Dieckmann condensation. If you have a diester, possibly you can do an intramolecular Finally, we'll take a look at intramolecular Claisen condensations called the Dieckmann condensation, and it gets its own special name, but it's really just another Claisen reaction all within the same molecule. So you've got to have a diester, and just like with the intramolecular aldols, you're generally only going to do the reaction if you can form a 5 or 6 membered ring. So if we look at the lovely diester I've got down below here, if you look, I've got a methoxide leaving group on my esters, and that's why I'm using sodium methoxide as my base. So again, whatever the leaving groups of my esters are, that's what I'm using as my base. And in this case, if I add it, this thing's symmetrical, so whether I show deprotonating the alpha carbon on this side or on the other side, that's the enolate I'm going to form. And then he could react with the ester on the other side. And again, I'm skipping steps. I'm not trying to show the mechanism, but these electrons will come right back down and we'll kick off that leaving group. So in this case, if we look at where we're forming the ring, it'd be a 1, 2, 3, 4, 5, 6 membered ring. And so we would predict it to be likely to form. And if I draw out that 6 membered ring, obviously the product's there, but I just want to show you how to actually arrive at that product. So if we draw out that 6 membered ring here, I could have this be carbon 1, 2, 3, 4, 5, and 6. And if we look at what's different here, so carbon 6 is a carbonyl. So, but he no longer is going to have an OCH3 attached. So, and then attached to carbon 1, not part of the ring, should be our other ester. And that's your product. So, and again, I didn't work out the whole mechanism and stuff. My goal was really just to show how to predict the product and just to simply present the Dieckmann condensation as a whole.